This is the examples of RC circuit. The switch in the circuit has been closed for a long time before it opens at t equal to 0. Find Vc for t more than 0. By referring to this circuit, you can see that the conditions of the switch is closed for a long time before it's open at t equal to 0. So there will be two conditions or three conditions if you are considering of the infinity. So first is t less than 0, t more than 0, and then t equal to infinity. The conditions of the circuits for the t is less than 0 is closed for a long time. So it means that this is closed. And then when the t more than 0, the switch is open with the t durations. And then when the t is infinity, which is it's open for a long time, and then the switch will be open. What information that you can determine from the three area? So for the first area, which is t less than 0, what you can determine is the values of V naught. And then for the t more than 0, the values of tau, which is in here, there will be a source in this area, which is when the circuit is opens, and then the circuit will have a source, either voltage source or current source. And then you need to find the tau by considering of R Thevenins and capacitor. So in this area, the step for finding the R equivalent is similar like for finding the R Thevenins. And then for the t is more than 0 till infinity, the switch is open for a long time, and then it will start to maximize chargings. And then what you can get from this area is you can get or determines the values of Vc infinity, which is the capacitor will be open. So the conditions of the capacitor when the t less than 0 is open, and then starting to charging or discharging. It depends on the conditions of the circuit, charging, discharging, or act like a source. And then the conditions of the capacitor when the t is equal to infinity is open. As for the step 1, you need to find the initial voltage Vc0 through the capacitor when the t is equal to 0 or the t is less than 0. So you can see that the switch is closed. When the t less than 0, the switch is closed. And then the capacitor is maximum charging, and then will be open circuit. So here the capacitor is open circuit, and there will be a voltage across the open circuit. You need to draw the circuit for the first step, which is t less than 0. Now you need to find the VC node here in order to determine the value and then substitute that into the equations. You can see that when the switch is closed, there is two sources that exist in the circuit. So in order to find the VC node, you can use any suitable methods such as mesh, nodals, superpositions, and all the suitable theorem that you already learned previously. I choose nodal for solving this circuit. As you can see here, this is the VC node that you need to determine. Therefore, you have to consider either the left loops and the right loop. In order to use the left or the right loop, you can see that there is a current I that flow to that branch. And by using the nodal, I choose that the current is exits the node. And then for the first equations of current, which is nodal is a summation of currents in one node is equal to the 0. Therefore, for the first branch, which is here, you can see that there is a 8 ohm resistor, and then there will be a 5 volts voltage source. The formula for this branch is V1 minus 5 over 8. And then for the second branch, that consists of 4 ohm resistor, the formulas of I will be V1 minus 0 equal over 4. And then you can see that at the final branch, there is a current source that is in the opposite directions of the currents that you are assuming previously. Therefore, the equations of the currents at that branch is minus 0, and that will be equal to the 0. You arrange the equation, and then the final values of V1 will be 7 volt. So here is 7 volt. Please remember that you need to find the currents I so that you can do a KVL equations at the left of the loop here. So I is V1 minus 5 over 8, which is V1 is 7 minus 5, 2 over 8. Then the answer will be 0.25 M. So here is 0.25 M. I select the left loop for determines the values of VC node. As you can see here, I choose this loop. So first is, in order to do the KVL, you have to remember that the steps of the KVL. What is the first step? First step will be directions of current I at branch. Number 2 is polarity of each element. Yeah. And step number 3 will be KVL equation. Therefore, for the first step, I am considering the directions of currents is exit the node, and then the polarities of the element, which is the resistor. This is the polarities of the voltage. You have to remember that you do a KVL equations KVL equation is summations of voltage. It is very important to know the polarities of each elements in order to do the KVL equation. So this is plus, and then for the dependent for the voltage source, so it already stated here, this one it will be positive. Okay, KVL at loop 1, as you can see here is, so I start with the 5 volt source with the clockwise. So I start from here, then should be minus 5, and then minus 6 times with I. Okay, and then plus VC naught, and then is equal to the 0. When you rearrange the equations, VC naught is 5 plus 6I, so 5 plus 6 times with 0.25. The answer will be 6.5 volt. In step 2, you need to find time constants of the circuit, which is tau. So in this condition, the switch is open. And then when the switch is open, the left side of the circuit is disconnected. So this is the circuits of the switch when the switch is open. You can see that there is a resistor, there is a capacitor, and then 4 ohm. So in order to find the RThevenins, you need to open circuit the current source. The step is same as the in Thevenin's method, which is in order to find the RThevenin, you have to terminate all the source. So from the capacitor side, you can see that the RThevenin is equal to 2 ohm is in series with 4 ohm, and then it will be equal to 6 ohm. And then the tau will be, the formula of tau is R Thevenin's times with capacitor, which is 6 times with 2. The answer will be 12 seconds. Step 3. The conditions of switch is open, and then you need to find the final voltage, which is VC infinity through the capacitor, which is this condition is the infinity, and then C is open circuit. Okay, so T infinity is mean that the T is infinity, and then the switch is open for a long time. So the keyword will be a long times, and then the capacitor is stable, and then achieve the maximum stage or maximum state, and then the capacitor will be open. This is the circuit when the switch is open, and then the capacitor is open. You can see that there is a source, which is a current source, 2 amp current source shown in the circuit. So there is no currents that flowing through the 2 ohm because of the open circuit at terminal capacitor. And then because of that, the voltage is 0. V is 2 ohm is equal to I R. When the I is 0, V is 0. So when the V is 0, okay, if the V is 0, it will act like a short circuit. Short circuit, voltage is 0.